So we can put in any x except for 5/4. So can you try to write the domain based on that information?
Yeah. Is it like the union thing that we were doing?
We are going to have parentheses and stuff. Yeah, and a union. If it helps, you can also draw a number line. Remember, this side is negative infinity. This side's positive infinity. 5/4. It can't be 5/4. So that's an open circle, but it can be everything else. So back to when we did this type of stuff, you can shade everywhere else except for 5/4. So can we write that?
Is it 5/4 comma infinity?
That sounds only like the right side. So we are going to use that. We are going to use 5/4 comma infinity, but it could also be on this left side.
Oh, yeah, negative infinity 5/4 for the left side.
Yeah. So if you follow it, it's negative infinity to 5/4 union 5/4 to infinity. So if I'm following along, always start on the left. Here's my little person walking along, starts at negative infinity, walks all the way over to here, and then stops because there's a hole. So we have to put something there, and then goes from here all the way to infinity and ends up over here. So if the
That's the
number
domain?
line helps, so if the number line helps, feel free to write a number line. All right. Any questions on that one? Any questions? No? Okay, so just to make sure we understand our rational stuff, number 2, is that rational or irrational? For everybody, rational or irrational? Number 2.
Rational.
Okay, I heard one person. Do you agree that it's rational, or do y'all disagree that it's not rational?
I agree.
Agree. Okay, number 3, rational or irrational?
Can y'all hear me now?
Yeah, we can hear you.
Oh, finally. And yes, it is rational.
Okay, number 3 is rational. I'm worried that only 2 people are answering or 3 people are answering. Number 4, rational or irrational?
Irrational?
Yeah. What makes it irrational?
That square root.
Yeah, that makes it not a rational function. Okay. All right, number 5, rational or irrational?
Irrational.
Okay. What makes it irrational?
The absolute value.
Okay. Number 6, everybody?
Um, rational,
I only heard one person.
I think.
There's more than one person.
I think it's rational.
Yeah,
Rational.
rational. Okay. All right, and then number 7, might as well just keep doing the last couple until we get to 9.
Rational.
Rational, okay. And then 8. Come on.
Irrational.
Irrational.
Okay, good. All right, number 9 is what we're at anyways. Let me see who's next in the group. Kathleen is next. Kathleen, can you do number 9?
It's not a rational function
Okay,
because of the square root.
good. And then can you state the domain?
So I wasn't sure about the domain.
Well, let's look at things that x cannot be. That usually helps. So what are some things that we can't do? Like we can't divide by x, right? Or 0. We can't divide by 0.
That can't be 0.
So let's look at that. What would make this 0? Can you factor?
If x were 9, that would be 0, right?
Why don't we factor it so we can actually get like a number? That might help. because 9 will give us a 0 on top, but we can have a 0 on top. There's nothing wrong with having 0 on top. It's 0 on the bottom that causes problems in our calculator, right? If we type any number divided by 0, we get like an error because it's undefined. So let's factor that out. Kathleen, do you know how to factor this?
I was doing it. I'm not really sure actually.
Is there anything they share that we can factor out? We always start with that.
So the x's.
We can take out an x. And what are we left with in our parentheses?
Is that x plus 1?
Yep, x plus 1. And then what do we do next?
You subtract it.
We got to split it first, and then we can do the subtraction. So x can't be 0. That's one of the things it can't be.
And it can't be 1.
Well, got to subtract the 1 over. So x can't be what? If I subtract 1 on both sides,
So it's 1.
-1.
Yeah, -1.
Okay, I thought you said 1. All right. Okay, so we know that those are two things x can't be. Is there anything else in the problem that we know that if we like plug in a certain x, it's going to cause an issue? Any other place? Anybody see any?
Wait, what was the question?
Anywhere else in this problem besides the denominator where there's restrictions on the x? Is there any other thing that if I plug in, it's going to cause a problem besides these?
The square root.
Yeah, square root. What kind of restrictions do we have around square roots? What can we not plug in?
A negative.
Yeah, we can't plug in negatives, right? So x has to be 0 or bigger inside that square root, or else we get a problem. So that's something else to consider. X has to be greater than or equal to 0. And I'll just write underneath here, due to the square root of x, so you know where I got that from. So all this information we just got, we got x can't be 0, x can't be -1, and x has to be greater than or equal to 0. This is why I like drawing a number line, because I feel like it kind of helps us figure out where to shade.
Excuse me, what are you saying? X is greater or equals to 0? It's when it's square root, it's x greater than 0 directly without equals.
No, you can take the square root of 0. It's just 0. You just can't take square root of a negative.
I'm talking about the greater than or greater and equal, greater equal.
Well, just the square root alone tells me x is greater than or equal to 0. I'm trying to combine all the information we've learned to figure out what the domain is. So
Okay.
I'm talking about just the square root means greater than or equal to 0. Now, we already found out earlier it can't be 0, right? When we did the factoring.
Yes.
So we're going to take that into account when we write our graph. But just that piece of the square root has to be greater than or equal to 0.
Is what I am talking about too. Okay.
Yeah, yeah. All right, Kathleen, so can you help me figure out where we would shade or draw or something on that number line? Where can x be?
It has to be greater than 0.
Yeah, and open or close? Oh, you said greater than, so open, right?
Yeah, and then to the right.
Yep, to infinity. All right, so can you write the domain from there? Does that help?
It might be worth stating, like when they ask for the domain, they're talking about the domain on the real number line. Because we can throw in negatives into the square root, but it's going to give us imaginaries, and that takes us out of the real number line.
Yeah, that's true. We're not looking at complex numbers here. We're not going to the imaginary graphing axis.
There's not really a very pretty way to graph imaginaries, if we're being honest.
Yeah.
Yeah.
All right. So Kathleen, given that graph, can you state the domain?
So it's just from 0 to infinity.
And what kind of, do I do parentheses or brackets? What goes around?
It's brackets on the 0 and then the parentheses on the infinity.
Bracket means it's equal. Can it be 0?
No.
No, so that means it's a parenthesis.
Yeah, it's included.
Not included. Parentheses not included, yeah.
Yeah.
All right. We are so kind of summarizing what we did. We looked at the things X can't be, like this and this. And then we saw that there was that restriction based on the square root of X, and that gave us this information. And then we took all three pieces of information about X and made a graph to try to help us draw the domain, write the domain. You don't have to write a number line. You definitely don't have to. If you already know the answer, you can write it, that's fine. I just think the number line helps a little bit, but you don't have to. All right, any questions on that one? No?
I want to go up, teacher, for the number 3.
Oh,
Please.
wait. I do have a question actually. Is that the only thing you write for the domain? Like we don't do like the union negative infinity comma -1.
Well, let's look at our graph. Is there anywhere else that's shaded?
No.
No, yeah, our little person, if we were gonna walk along the shaded area, would start here and walk this direction, and then they'd be done. So just that one area.
Are we okay? So we're only shading the right of the like to the right of the 0 because that would be greater than 1.
Because this piece here told us it has to be greater than 0. It has to be a
Okay.
positive number. Yeah, it has to be a positive number. And Ganya, did you have a question? Were you
Yes, please. I want to just ask about the number 3. It's irrational, right? Because it's just a polynomial, quadratic.
Yeah,
formula.
that's just a parabola. That's just a quadratic. So that's just negative infinity to infinity.
Yes, it's not. It's and the number 2.
Number 2 is everything except 0.
Yes, it's everything except the 0. It's in this case, it's irrational.
Is that one irrational or rational, Professor Sievers? I thought we
Which
said that
one?
one was rational. Number 2?
Number 2, 6 over x squared.
Yes, please.
Yeah, that's rational. It's a polynomial over a polynomial. 6 is a polynomial. X squared is a polynomial.
Because the degree here, we don't have the degree of the numerator.
But
We have
we can rewrite it as 6x to the 0 over x squared.
Okay, thank you.
Yeah, monomials are a polynomial, even if it's just a constant.
Yeah.
Because I think we had that in something else too, maybe.
Because teacher here, excuse me, I have another question. Because if we are looking to the asymptotes here, our horizontal asymptotes, it's 0, right?
Mhm.
I know it's not connected to our class. Want to just ask? It's just a question.
Yeah,
That's coming up.
Yeah.
Okay, thank you.
Any other questions before we get started on the next section?
I was gonna say, like, when they ask for the domain in this class, what you really want to think is like what the domain cannot be. And there's basically 2 restrictions that we're gonna have, 3 restrictions when we get to logs, but we're not doing logs yet. So there's basically 2 restrictions you have to look for at this point. One of them is thou shalt not divide by 0. And the other one is the thing inside your square root cannot be negative. Like if you can remember those 2 things, you can get the domain or get at the domain somehow.
Those are your 2 things. The denominator can't be 0, and whatever's inside the square root has to be positive, or it has to be 0 or positive. So
About if we have the denominator is an absolute value as an x plus 1.
then that's going to give you a positive no matter what. So that's fine. That won't make the denominator 0.
But in this case, the domain, it's going to be a -1 plus infinity.
Oh, wait, no, it can be 0. Sorry, it can be 0. I thought you were talking about square root. Absolute value can be a 0. So you would still have to look, if the absolute value is your denominator, you would still have to look and see when it gives you a 0.
Yes, what I'm asking for, because if we have the denominator as an absolute value for the x plus 1, and x plus 1 is greater or equals than 0, it's going to be x greater than -1, and the domain is -1 plus infinity.
You're talking about number 5?
No, it's not connected to other in this case. It's just
Oh.
my, it's
Oh,
just the question.
yeah, pretty much anytime you have a denominator, you have to set it equal to 0 or not equal to 0 to figure out what the restriction is. So
But
you're
if it's the
saying that if you have absolute value of x plus 1, then you'll never get a 0, right?
Yes.
But you can get a 0 because you could plug in -2 for -1, for example. Absolute value of -1 plus 1 is 0. Absolute value of 0 is still 0.
I want to look here. We have number 5. What is number 5?
Because you have to do the denominator first. I mean, sorry, you have to do the inside the absolute value first. So if you have absolute value of x plus 1 and you plug in -1, that's going to give you 0.
Yes, but I'm asking if it's the absolute value x plus 1 is in the denominator. It's in the bar.
Yeah.
It's not
Yeah, if it's in the denominator, you still say it's not equal to 0 and you still solve it. Yeah.
But it's an absolute value, teacher. I can't say it's not equals to 0. It's an absolute value. It's going to be greater or less.
But the
It's not
inside
putting-
cannot be 0, right? Because if the inside is 0, then you're dividing by 0. So you have to set the inside not equal to 0.
Because, okay.
Yeah, your domain restriction would be x equals a -1. You wouldn't be able to do that.
Yeah, so if you're giving the example of absolute value of x plus 1,
Yes.
that means that x plus 1 cannot equal 0. So that means x can't be -1. So if I plug in -1, absolute value of -1 plus 1 is absolute value of 0. So
Yes.
that is a restriction. So
In
you
this
can't
case,
have-
my domain is going to be what?
your domain would be -infinity to -1, comma, or union -1 to infinity.
Okay. I see. Thank you.
All right. Okay. So hopefully everyone was listening to that. That was a good question. What do we do if an absolute value is on the denominator, right? Hope everyone was kind of following along with that question because that could come up.
Have we done things where we solve with absolute value and we separate them into two different things?
No.
No,
Yeah.
we didn't.
No.
Okay. Are we doing that in this course?
No.
I don't know. You're the one you've taught this course several times. You should
Yeah,
know.
but they change things around on me and I forget what's in there and what's not.
All right. So 15. What are our horizontal and vertical asymptotes? Who's next? Let's see. Kayla, you're next. Did you get to that problem? Kayla? Okay. Vanessa, did you get to that problem?
I was confused on it.
Confused? Do you know what an asymptote is?
Yeah, I was confused on how, like, where you find it at, like the number for it.
Okay. So what's an asymptote? Why don't we start with that? Because if we're trying to identify them, we got to know what it is. So what is it?
Because I understood it as it's like the gap in there of the graph.
Oh,
the-
are you talking about piecewise? Like when we have when it's like this? Is that what you're talking about? Are you talking about like when there's a jump?
No, I think that's what confused me though. I think I misunderstood it.
Okay.
On what it meant.
So an asymptote is like a stop sign or like a do not enter. Like you can't cross it. So your function, it can go close to it, it can tiptoe next to it, but it can't cross it. So are there any places on this graph where the line is, or our function's not crossing it? Like it's going close, but it's not crossing?
Would it be the bottom two?
The bottom two? So tell me where. Can you tell me like maybe a number or something, or so I can know where you're looking at?
Would it be the ones that are by the like the -5?
Okay. I think this is what you mean, right? I think that's a -4.
Yeah.
Yeah. So that's a -4. And is it x equals -4 or y equals -4?
Would be y.
Yeah, y equals -4. So that's one of those asymptotes. And what's the vocab word when it's flat like that? Is it horizontal or vertical?
Vertical.
Vertical is up and down.
I mean horizontal.
Yeah,
Sorry.
horizontal.
Horizontal.
Like the horizon, right, with the sun coming up over the horizon. So this is our horizontal asymptote. All right. Any other places that our graph can't cross?
So is it when it's not touching the graph?
Yeah, like it's like the blue is our function and it's going really close, like tiptoeing right next to it, but not crossing it. It's like that whole, at least my younger brother used to do the whole, I'm not touching you, but he's like right next to my face. Yeah, it's like that.
So would the one on top that touches the 0 not count because it's touching it?
Well, yeah, 0 would not be an asymptote because that's touching it. So let's look at the y equals -4 again. Do you see how there's like this dashed line that's representing that? That's like the line that says do not cross, like you cannot cross that. Do you see how I kind of like highlighted it red again?
Yeah.
So are there other lines like that that we can't cross?
Would it be the vertical lines that are going?
Yeah, So where are those at? Tell me what numbers.
Would it be the -2?
Okay, and was that an X or a Y for the -2?
Would be X.
And then there's another one also, right?
Would that be -3? I mean +3?
I think it's a 2 still, because there's a black line right there. I think it's still a 2, yeah. And these are both the vertical asymptotes, right? Because they're going up and down as vertical. Did anyone else have siblings that did that to them? Or was mine the only lovely, wonderful sibling who did that to me?
No, mine was annoying like that too. I had 2 of them, older ones.
Mine are all younger, so I got a lot of the whole like, I'm not touching you.
I was a younger brother, and then all my cousins were boys, and I was the youngest cousin too. So I got picked on a lot.
Well, if anyone's had that experience, they'll know what I'm talking about. All right, Vanessa, let's talk about the domain. So tell me some, remember domain is X's. So tell me some X's that we're not allowed to have in this problem. Looking at our blue, where's some X's that I'm not allowed to have?
Is it when it goes past it?
Like it can't cross it, right? It can't have it. So let's go along our X, right? This direction. Anything that we cannot have for an X and we can't cross.
Would be a -3.
I think it's still -2, right? This spot is still -2. So X cannot be -2. And what else can X not be? What's the other place X cannot?
+2.
+2. So given that information, I can draw the number line if it helps you. Remember, we start -infinity, -2, +2, +infinity, open circles, and a shade. It can be anything except for those 2 numbers. So can you try to write the domain?
Would it be infinity and +2?
We want to start on the left though. That sounds good if you're starting on the right, but we always start on the left. So my little person is going to start on this side. So it's going to start at the -infinity and then it's going to walk that direction.
So would it be -infinity +2?
We have a stop before that, don't we though? Before the 2, isn't there a place we have to stop first?
-2?
Yep. So -infinity to -2. So now my person is stopped right here. And now I'm going to keep walking. So I'm going from -2 to where? Where's the next stop?
+infinity?
I got to stop somewhere before that. I have to stop another place before I get to the +infinity.
It would be +2?
Yep, +2. That's my next stop. And then another union, and now I can keep going. I'm at 2 going to
positive infinity.
Positive infinity. Yep, there you go. Awesome. So if it helps you to put like a little person on the left and like think about where they're going and where they have to stop, that might help. Okay. All right, any questions on that one? I know a lot of y'all didn't get to this problem, so did you have questions on that?
Why is the domain like different on this one?
Oh, there's 3? You mean there's
Yeah.
because we have more places that X can't be. That's why on our number line, there's more places that X cannot be. So we have to write more pieces.
How come, like on the other ones, we didn't shade in like the middle?
We didn't shade in the middle because X couldn't be those numbers. You're talking about number 9. Yeah.
Okay.
Okay. Any other questions on this one?
Yeah, I don't know if it helps, but the unions represent what you're skipping. So like if you're skipping 2 numbers, you should probably have 2 unions in there.
Mm-hmm. It's like stops, like you haven't stopped to go to the coffee shop first, and then you're going to breakfast, and then you're going to work. All the stops. Places you have to stop at. Okay. Any questions at all? Feel free to ask. No? Okay. All right. Well, we'll go back to groups and we'll keep going. We're doing 25 and 33. We're doing these next. So I know those were in the video. So let's see with your notes if you're able to start working on those. So it was 25, 33, 41, and let's see. Oh, this is blank. Oh, it must be down here with the graphs. Okay, let's do those 3 first before we move on. Let's see whose turn it is. It is Brian's turn. We can't hear you, Brian, if you're saying anything. Your mic's not working again. All right, we'll skip your group. I'll come back to your group. Let's see, group 3. Let's have Joshua go first.
So for the vertical asymptotes, I got x equals 3. So I took the 2x minus 6 on the denominator. Set that equal to 0. So I did plus 6 and then divided by 2, which gave me 3.
Okay, so that's the vertical asymptote. And then horizontal?
Were there none?
Well, there's a horizontal asymptote.
There is? Okay, then was it negative 1/3?
No. So maybe we should write these rules out if we don't remember them. So there's 3 things that can happen. You can have 1, the degree. I'll write it like a fraction. The degree like this. So the top is higher. If the degree on top is higher, then we have to do this thing called long division. So we probably won't run into these since we haven't learned long division. I'm not forgetting we did long division, am I? We didn't do it. Okay, so that's what would happen if the degree on top is higher. We haven't learned that, so you won't have to do that, but just so you have that for your reference. If the degrees are the same, the degree on top and the degree on bottom is the same. So I'll just write same, same. Then we take the coefficients of the leading terms and we make that a fraction. So we take the coefficients of the leading terms and divide them. oops, I need another I there, divide them. Okay. And then the third option is if the degree on bottom is higher. So the degree and then the degree on bottom is higher. If the degree on bottom is higher, then our asymptote is automatically y equals 0. So that's an easy one. Those are the three different situations you can run into with horizontal asymptotes.
Okay.
So in this case, which option is happening? One, two.
Number 2.
Number 2. Okay, so we're going to find the coefficient of the leading terms. So that's a 4 and a 2, and we divide them.
It's going to be 2.
Yep, so y equals 4 divided by 2, so that's just 2. So our horizontal asymptote is y equals 2.
Yeah, we don't do long division or slant asymptotes in this class. So if it's higher on top than it is on bottom, then that's pretty much it. We're just going to assume that there's no asymptote. If you just tell me there's none.
Yeah. So this would mean no horizontal asymptote.
If it's bigger on bottom, that's just use like start with 1/2, 1/3, 1/4, right? Half, third, fourth.
I think I was getting confused because I forgot the degree was the like the exponent, and I was just looking at the coefficient being higher. But I see what I'm doing now.
Yeah, so that the degree is going to affect it more than the coefficient, right? Like if we think about like how things grow and how things shrink and stuff like that, your degree is what's really contributing to that.
Okay.
So those are your three possible situations that you could run into. If you run into the first one, we're going to say no horizontal asymptote because that's technically a slant asymptote or an oblique asymptote, which we haven't done. So, but those are the three things you can see. I wanted to show you all the options. So you're not like, well, what happens if the degree is higher on top? Now you know. So those are all three options. Okay. All right. So we're done with that one. Any questions on that one before we go to the next person and the next problem?
I was gonna say if you're unsure, you can always check like Desmos or something like that too.
Well, I can't on a test, but on your homework, yes, you can check Desmos and a graphing calculator to verify your answer, but try to do it yourself first because on the test, you won't be doing that. Okay, any questions on that? No? Okay, next person. Next person in room 3 is Fernanda. Fernanda, can you do number 33? Fernanda, are you here? Okay, we'll go to the next person. Let's see, next is Michael F.
I'm so unsure on all this. I'm just trying to follow along and get an understanding of it.
That's okay. Which one do you want to do first, horizontal or vertical?
Let's do, I guess, horizontal.
Okay, horizontal is those 3 rules that I just wrote down. So which case or which situation do we have here?
I don't really know, but I would think that with there being a power, the bottom would be bigger.
Yeah, the degree's higher on the bottom. There is no degree on top, right? The x would have a 0 degree. So the bottom definitely is bigger for the degree. So what's our horizontal asymptote?
Horizontal, would that just be the 0?
It's y equals 0. Yep, automatically. Those are the easy ones. You're like, oh, the degree on bottom's bigger? Yes, it's y is 0. Done. Those are the easier ones to do.
Okay.
All right. So let's try vertical asymptote next. So if you're not sure how to start it, you can look at what Joshua did. How did he find his vertical asymptote?
I'm not sure I followed that too clearly either. Let's see.
He wrote something is equal to 0. What did he write was equal to 0 when we did that one?
X. I mean, that'd be the only variable you would have, right?
I think he said 2x minus 6 was 0. Do you have that on the last problem?
Yes.
So that was the denominator. So we're going to do the same thing here. So what's our
Okay.
denominator?
2, I'm sorry, x to the second minus 5.
So we're going to make that 0, and then we're going to solve for x.
Okay.
So I want to move everything away from x.
2.5.
Well, let's add the 5 first. So we have x squared equals 5. How do we get rid of a square? What's the opposite of squaring?
It'd be dividing.
Oh, that's opposite of multiplying. Opposite of squaring is square rooting. So we're gonna square root. So remember, when we square root, we have to have our plus or minus. Don't forget that. So we get x equals plus or minus square root 5, because that doesn't break down. And that's it. Those are our asymptotes. So to get the horizontal, you look for which case it is that I wrote of the 3 cases, and then you do that. To get the vertical, you just make the denominator 0 and solve. Okay. All right, next person in your group for number 41, unless there's any questions. Okay, next person in your group is Fidel. So we're doing
Number 41, right?
Yep, number 41.
Okay.
Oh, I don't know why.
So for the vertical asymptote, I took x plus 3, then I set it equal to 0.
Hang on, still erasing. All right, 41. Okay, so x plus 3 equals 0.
Yeah, so I got x equals -3.
Good, so that's your vertical asymptote. All right,
Right.
and then for horizontal?
Could I just take the x squared minus 9, also set it equal to 0?
Oh, what's going to be one of these 3 cases? Which case is this? Is the degree on top higher? Are the degrees the same? Or is the degree on bottom higher?
Oh, the degree on top is higher.
So that would be
Uh,
long division, but we haven't learned that. So we instead are going to write no horizontal asymptote.
Oh, okay.
Because technically it's a slant asymptote. So there's technically no horizontal asymptote. That's it.
Teacher, I think we did some mistakes here because we have the equation as a x squared minus 9 over x plus 3. I think we need first to find the solution for this polynomial as x minus 3 x plus 3. Cancel x plus 3 x plus 3. It's going to be f of x equals to x minus 3. In this case, we don't have any horizontal line or vertical line asymptotes. Because
so technically what you're saying, if we actually solve this out, is the x plus 3's will cancel and we get what's called a hole. So yes, technically we have a hole at x equals 3, -3, and then you'd have to get your y, you'd have to set it, solve it. We don't have vertical asymptote. But did you talk about that, Professor Sievers, in your video, or are you just having them go based on that rule? Do you want them to solve it for the hole? Or would they say that this is their vertical asymptote? Because technically 41, there's a hole, technically, but I don't know if you talked about that or not.
Because it's in a polynomial, we have this thing as everything it's squared. It's we can cancel the whole what we need to cancel. It's going to be just a polynomial with first degree.
Yeah, I thought.
It's a polynomial, but it's a polynomial with a whole. So
Yeah,
do you want them to
but
simplify it and find the whole, or do you want them?
Yeah,
to
I thought we
do
talked
vertical?
about holes in the lesson. Did we not?
I don't, that's why I'm asking you. I don't remember.
I thought I did.
because in this case we are going to have no vertical asymptotes and no horizontal asymptotes.
Yep. Yeah,
Yeah.
if you graph it on Desmos, you can also see the hole.
They're gonna have a
Right.
hole. Okay, so there's no vertical asymptote. I didn't know y'all
No.
did that in the video, so that's why I was asking Professor.
Because in this case, teacher, I think we don't need to see the video because we have the fraction, the equation.
No, I understand, but I don't know what
Right.
if he told you to do that or not. That's why I was asking Professor Sievers. Just like
Okay.
up here, right? I said long division, but if we haven't told you to do long division, then I'm not going to tell you to do that. I'm just going to say write none. So that's why I was asking Professor Sievers. So we're not going to write x equals -3 as a vertical asymptote. We're going to write none because we can simplify this. And when we simplify it, we see the x plus 3's cancel. And that gives us a hole at x equals -3.
Right.
And then we plug in the -3 to get the -6. Okay. It didn't mention holes anywhere in the directions or the stuff I saw. So that's why I didn't know that you did it.
I think I did it. It's been a
I
year.
don't know. That's why I was asking you. Because I didn't see it. That's
Sorry,
why
guys, I make you sorry. It's just my thoughts.
this is the hole. So you should write it as a point. I found the x and then the y, and then I rewrote it as a point. So here is the hole. Well, y'all can tell me, did anyone else see hole in the video? Was that in there? Find the hole? Y'all watched the video, so you should be able to
I
tell
see
me.
it while again. Why I see it have a while when
Is there
I
anything
saw.
about holes in the video?
I don't think so.
But
Today's
it's
video,
like
right?
automatically it's going to be the same. Like
We may not talk about it till later too.
Yeah, that's why I wasn't sure.
It
'cause
might
didn't
come up when we
say.
start graphing these things. I don't know if there's a separate section. Like I said, like
Yeah.
they've redone this class and made things different, and they've kicked stuff in and kicked stuff out. And I also teach another class that is like almost parallel to this. You know, that 13, 14 is like almost the same thing, but just the college part. And we do go over it in that class. So I don't know if I thought I said it in the video, but it's possible maybe I didn't.
All right, so we're just gonna assume we're doing holes. Does anyone have any questions on why we have a hole or how we found the hole, since it seems that not a lot of y'all knew about this ahead of time or already understood it? So any questions about that? Like why we have a hole or how to get it? Any questions? So we're all 100% fine. So we can put a hole on the test and we can put a hole on the final, right? We're good? No questions?
you mean if we're going to have the same equation or whatever, you want us to write as no vertical, no horizontal, or a hole?
Then you also
because sometimes of the explanation now it's going to be like literally, right?
Well, that's why I was asking Professor Sievers, because if you don't find the hole and you just straight up do the rule for vertical and horizontal, you wouldn't realize that was a hole. That's why I was asking.
Because it's automatically when we find no horizontal line and no vertical line, it's small.
But without simplifying it, you wouldn't know that it was a hole and you would think it was a vertical asymptote. So that's the reason I asked. So any questions on that, on the hole, how to find the hole? Please ask now if you have questions. No? Okay, just because it seems that this is something new or something that a few of you maybe didn't know about, let's look at 39. On 39, what cancels? What can I cancel?
X plus 2.
X plus 2. So that means there would be a hole at x equals -2. So I'm giving you another example with a hole. And then to find my y, I would put it into my reduced fraction. So I would plug in the -2. So that means my whole is going to be -6 over -3. So that gives me a 2. So my whole is -2, 2. So there's another example of a time when you can reduce, which creates a whole. Anytime you cancel x's like that, it creates a hole in your function, in your polynomial.
I should have said something about it when we did problem 6, find the vertical asymptotes. The h of x function should have a hole in it, it looks like. So if you want to go back, look at that in the lecture, it should be problem 6.
And does that make a little more sense? Do you need another example? Are we okay? Are we not okay? Like, I need feedback from y'all. I'm literally doing this because I think you had questions. So you got to give me feedback.
I don't know if I said it was a hole, but it does say cancel common factors before we find the vertical asymptote.
Okay.
So maybe I didn't say explicitly it was a hole.
Okay. Well, now they know.
Now you know it's a hole, don't fall in it.
Yep, don't fall in the hole. So no one is saying anything. I'm getting no feedback. I'm getting like, yes, I got it, or no, I don't. I'm getting nothing. I have no idea where you're at.
It's mostly interested. I didn't think to ask anything about that because I don't feel like it was mentioned. Like I didn't even know I didn't know that, if that makes sense.
Yeah, but now, do you have questions about it? Now that we've kind of talked about it a little bit, are there questions about it?
Got a pretty clear understanding.
Okay.
I understand it. Yeah.
Caitlin, Joshua, Fidel, Vanessa.
Yeah, it makes more sense now.
Okay. Do you need another example with a hole, or are you all okay and we can move forward?
I'm good. I think I understand it.
All right, we'll move forward then, since Fidel's the only one who told me anything and he said he's fine. All right, we'll go to 43 to 46 next. 43 to 46. Looks like these have graphs and it wants you to match them without a calculator. So these should be a little bit quicker because you're matching. So we'll do those. And then, see, none of these have a hole either. Okay, and then we have 121 and 125. So hopefully we'll have time to get to those. If you finish early, start 121 and 125. If you finish the matching before I bring you back. Okay. All right.
I definitely talked about holes.
Well, I'm glad you checked.
Yeah,
'Cause
like I
was
went
like,
to
well,
Desmos graph and I went over it like pretty
uh,
well.
It seemed like nobody knew what I was talking about except for
Yeah.
Danya, which is, I don't know, maybe they didn't watch it. I don't know. Or maybe
Yeah,
they
that's what I'm
forgot. 'cause it
thinking.
was a lot of information.
Yeah, I mean it is an hour-long lecture, so maybe not. But like, I mean, I did spend like a good minute over it, and I went to Desmos graph and even showed him the hole in it. So
Oh,
I definitely went over it.
maybe it's a early Wednesday and their brains are asleep. I don't know.
I'm trying to look at the analytics to see how many people watched it.
I hope they all watch it. I hope they don't just have someone watch it, take notes, and then send it to each other. I hope not. The videos are helpful.
It's 446 is what we're in, right?
I was surprised that it wasn't in the directions. That's what threw me because I just skim your video. I don't usually sit and watch the whole hour because I already know the material. And I just didn't see it. I must have fast forwarded past that spot. And then the directions didn't have it either. So I was like, oh, I guess they're not doing that yet.
Last 7 days. That's what we look at.
Oh, it's 1:30. Are we done at 1:30 or 1:40?
140.
1:40. That's what I thought. Oh my gosh, my brain is done this
It
semester.
looks like a dozen people probably watched it.
Okay.
But it didn't show the days numbers though, does it? No, not yet. So if they watched it this morning, it might be more. Looks like 5 and 7 is the views in the previous 2 days. So it's cool. But it also looks like average duration views 15 minutes, and it's an hour-long video, so I don't know.
Oh, they're not watching the whole thing then.
Yeah. Or they're watching it in parts.
But then it would show more views if they did that.
Yeah.
That means those like 7 views, really, it's only like 1 or 2 students. So they're not watching the videos then. Well, it sucks. It only hurts them though. And they haven't been really coming to the IA hours as much either. Have they been coming to your office hours and asking a lot? No. I don't know. We can only be there for them as much. I mean, we can just be here for them and they either reach out and get help or they don't. I don't know what else to do.
Yeah, maybe a short word of encouragement, like, hey, you're here. Most of you are like capable of passing this class. You don't want to throw that away.
I know a lot of them could pass. I mean, almost everyone that's left could pass.
I mean, we getting paid the same way either way. Like, it's not like their actions don't affect us like as much as they're affecting themselves.
I know, that's why I keep telling them, reach out for help. Like, we're here, you know.
Like, this isn't high school. You're not getting in trouble for it like you would in high school, you know. It's like,
Yeah. I had to have a conversation like that with one of my students in my other classes because he just really didn't do anything for the semester. So then at the end, he's like, oh, well, I feel like I didn't learn much. And I was like, well, let's be honest, like, how much practice were you doing? Because you never asked me a single question the entire semester and you weren't really doing any practice that I could see. You weren't, of course, you're not going to learn anything. Like, I'm here, but you got to show up too. It can't just be me talking or me saying I can help you. It's got to be both parties. Just like a relationship, it's got to be both people. Communication. Are you gonna be able to grade Michael's before I meet with him? Because he set up a meeting with me.
Was it today or when?
He set up a meeting today at 3. And then
I mean, I'm working on them right now, so I don't know.
Okay.
My next goal is to get these done, so hopefully.
Okay.
But it might be close.
Well, if you end
Already
up,
2 o'clock now.
I know. Well, if you end up getting to pick which test you grade next, you might just want to pick his just so that I can talk to him at 3 if you start a fresh test.
Okay.
It might be helpful. Otherwise, he might ask me to like fake grade it to see what he thinks he got. I'm not sure what he's gonna ask, so. But, okay, we'll bring them back. And let's share again. Well, I hope they reach out and I hope they study. They're here to help. They have been here to help.
That's it. No, it's not it. Am I recording all this?
I don't know.
Apparently.
Did you pause it?
No.
43.
So for the horizontal asymptote, they have the same power on top and bottom, so I just did 1 divided by 1.
Oh, the A is not an X though. The A
Oh.
is like any number, like 2 or 7 or -3.
Oh,
So the bottom will technically be a higher power.
oh, okay, I see. Okay, I did this wrong then.
Okay, so that means the horizontal is y equals 0, right? And then what'd you get for the vertical? X equals what?
1.
1. Okay, so let's pick which graph that would be.
I chose the wrong one because I did it wrong. That would be B, right?
Yeah, it looks like B. Looks like this one down here. So this one's number 43. Awesome. Cool. All right, let's see. Jade, you're next in that group.
Okay, so I have been having trouble understanding this. We're on 44 now?
Yep, we're on 44.
Okay.
So which case is it? Is it the case where the degree on top's higher, the case where they're the same, or the case where the degree on bottom's higher?
Sorry, I couldn't hear you.
Is it the case where the degree on top is higher, the case where the degrees are the same, or the case where the degree on bottom is higher?
Bottom is higher?
What's the degree? The degree on the exponent, or the x, like what's the exponent on the x?
There isn't one.
There isn't one, so it's a 1, right? So are they the same, or is the one on top higher or the one on bottom higher?
So the one on top is higher. Sorry, I was looking at 43 and then I processed, you're talking about the like exponent, and I was like, okay, that's anyways.
Okay.
I understand where we're at now, and the bottom is higher, correct?
The bottom has a degree of 1.
Or I mean the top.
What's the exponent on the x on top?
2. Or
That's
there's
the
no
whole-
exponent, not coefficient, exponent. There's no exponent.
So they're both 1, right?
Oh yeah, so it'd be the same.
They're the same, so that means we divide their coefficients. So 2 over, this has a coefficient of 1. So it's just y equals 2.
Okay.
And then what about the x, the vertical asymptote?
I'm not really sure.
We set the denominator equal to 0. So x minus 1 equals 0.
So it'd be x equals 1, right?
Yeah, exactly. All right, so which graph matches that?
Okay.
Which has a y of 2 and an x of 1 for the dashed lines.
Sorry, they're like scrunched because I have my screen split, so I'm like scrolling to see them. Okay, would it be A?
Yep, A. This one's 44. All right, I know we're at time here, so the last one, let's at least say what 45 and 46 are. 45 is gonna have y is 1 and x is -2. So this one's 45. Is that what you got?
I think 45 is
Oh wait,
D.
no, that's not that one. Which one's 45?
D.
D?
Yes. And 46 is
But
D.
x is -2 is your vertical. Oh yeah, there it is. Okay, yeah, 45. I had that. And then 46 must be this one.
Must be C, right?
Yep. All right, I know I gotta let you go because it's already 3 minutes past. But remember, drop deadline Thursday. And if you have questions, need help with anything, we're here. That last push, right? 4 weeks left. Actually, 3 weeks left. You got this. You can do it. All right, we'll see you tomorrow.
Teacher, please, how about there was 121? I would like to, or can I go back or whatever?
121?
Yes. Please.
What was the question about 121?
Because it's like, I can't understand it because we have graph like time.
Are you talking about A or B?
The whole thing, because I didn't understand it. I don't know how.
Okay, so A is asking evaluate T of 4. So that means you need to look at the graph and see when the traffic rate is 4, what is the weight? So if I look at 4, I know you can't, it's hard to see, but if I look at 4, it looks like the traffic weight is less than 1. It's pretty small. So T of 4 is like maybe 0.1. It's very small, maybe 0.2.
Here, teacher, we don't have the fraction of the equation, right?
We do. I mean, you could plug it in. We could plug it in also to verify because I'm just using the graph to say that. So based on the graph, I think it's very small. So why don't we actually plug it into the problem? So T of
1 over 8,
4,
maybe.
-1 over 4 minus 8. So that's -1 over -4. So that's 1/4. Hey, I was close. I said 0.2 and it's 0.25. Very close.
Yeah, you're smart.
Well, it was just a guess on a graph. We're good. It was close.
Okay.
And then it says you have to interpret. So that means that when the traffic rate is 4 cars per minute, then the weight is 0.25 minutes.
Like we need to give the time here, right?
Yeah, they just want it in context. They want like a sentence, basically.
Okay.
And you also have to do T of 7.5, but we're gonna do the same thing. You're just gonna plug it in again.
I think that was question maybe.
T of 7.5 equals -1 over over 7.5 minus 8.
It's like we need just to upload this point to find them and to interpret the results, right?
Yep.
Thank you. How about, can you go down a little bit, please? I want to 125.
Okay.
Please.
It wants you to graph that function.
Okay.
Sorry?
Because I started to graph it and then I think I don't know where I did mistake. So
it wants you to graph it in the calculator. It looks like it wants you to graph it in the calculator and it wants it to be 0 to 14. And 0 to, like, it wants you to basically just graph this part 0 to 14, like this window. Just
you are okay. Okay. You're showing me in this case. Okay, thank you.
Yeah, it just wants this part in the calculator. It wants 0 to 14. It
like
only
this
wants,
quadratic.
Just this part. So in your calculator, when you graph it, you can tell your calculator what the window is. Like if you hit window, you can tell it that you want it to go from 0 to 14 on the X and 0 to 14 on the Y.
Because I did it manually, I can't do it by calculator.
You can do it on Desmos.
It's like what, 106 or something.
You could do it on Desmos if you want, or if you want to do it by hand, you'd have to just make a table and plug in 0 to 14 each one.
Okay.
And then graph that.
And then they asked about the number of population. What happened for something about the population? I don't know.
Yeah, the initial population. X is 0, X is greater than 0 is in months. So if it's been 0 months, how many bugs were there? How many insects? You can plug in 0 and you can find out that there were 11 insects.
Okay, thank you.
Uh-huh.
Thank you so much.
Yeah, no problem. Anytime.
Sorry. Sorry.
Okay.
Okay, have a good day, everybody.
You too.
See you
We'll
tomorrow.
see you